You know, math is really its own kind of language. And just like any language, it's got to have rules, right? A grammar that makes sure we're all on the same page. Without that, it's just chaos. So today, we're going to dive into the most important rule in all of math grammar, the order of operations.
All right, take a look at this. Seems simple enough, doesn't it? Just a couple of basic calculations. But here's the thing. If you ask two different people to solve this, you might actually get two completely different answers. How is that even possible?
So what's going on here? Well, somebody might see that 2 times 2 and think, oh, I'll do that first, that's 4. Then they do 28 divided by 4 and get 7. But someone else might just work straight across, from left to right, and they'll end up with 28. This is exactly why we need a universal system. Without it, math just doesn't work. Only one of these is right, and we're about to find out why.
Okay, before we dive in, let's just get a quick term out of the way. What we're working with here is called an expression. It's basically just a math problem without an equal sign. Our job is to simplify it down to just one single number.
So, how do we fix the confusion? We use the order of operations. I want you to think of it like a 4-level hierarchy. You have to take care of everything on the top floor before you can move down. At the very top, we have parentheses, anything in grouping symbols. Below that, on the second floor, are exponents. Then we get to the third floor, multiplication and division. Now this part is absolutely crucial. They're on the same level. You just work from left to right, whatever comes first. And on the ground floor, same deal with addition and subtraction, left to right. This little hierarchy is the key to everything.
Okay, theory is great, but where the rubber really meets the road is in practice. The only way to get good at this is to just, well, do it. So let's run through a bunch of examples.
All right, let's look at our first example. We've got subtraction, multiplication, and parentheses. Looking at our hierarchy, parentheses are king. They're on the top floor, so we have to go there first. So 3 plus 4 gives us 7. Now our problem is 5 minus 2 times 7. And here's where people get tripped up. It's so tempting to do 5 minus 2, right? But nope, multiplication is on a higher level than subtraction, so we have to do 2 times 7, which is 14. And only then, at the very end, can we do the subtraction. 5 minus 14 is negative 9.
Okay, let's level up and throw an exponent in there. We've got multiplication, an exponent, and subtraction. So we check our hierarchy. Exponents are on level 2, way above subtraction on the ground floor. So our first move is 2 squared, which is 4. Now the problem reads 3 times 4 minus 4. Multiplication is next, so 3 times 4 is 12. And the last step is simple. 12 minus 4 leaves us with 8.
Pay close attention to this slide, because this is probably one of the biggest traps in all of algebra. It's all about those parentheses. On the left, the parentheses are like a little force field around the negative 3. They're telling us to square the entire thing. So negative 3 times negative 3 is a positive 9. But on the right, no parentheses around the negative sign. That means the exponent only applies to the 3. So we do 3 squared, which is 9, and then we tack that negative sign on at the end. It's such a tiny detail, but it completely flips the answer.
So let's see that rule in action in a bigger problem. First thing we spot are those parentheses around the negative 3, so that exponent turns it into a positive 9. Great. Now we're left with addition, subtraction, and multiplication. We know multiplication is on a higher level, so we handle the 5 times 2 next. That's 10. All that's left is 9 plus 6 minus 10. Since addition and subtraction are on the same level, we just move from left to right. 9 plus 6 is 15, take away 10, and we get 5.
Okay, deep breaths. Let's talk about fractions. I know, they can look a little scary sometimes, but I promise you, the order of operations works in the exact same way.
Super quick refresher, just so we're all on the same page, the number on top is the numerator, the number on the bottom is the denominator. Simple as that. Let's move on.
Now, when you're working with fractions, there are just a few special rules you got to remember. If you want to add or subtract them, the bottom numbers, the denominators, have to be the same. Multiplication is the easy one. You just multiply straight across the top and straight across the bottom. And for division, you just do this little trick. You flip the second fraction upside down and then you multiply. That's it.
All right, now that we've got our fraction tools, let's get back to it. Just remember, these might look different, but they're just numbers. And the same system, our good old order of operations, still runs the whole show.
Okay, look at this. You've got addition and you've got division. What do you do first? Come on, think back to our hierarchy. Which operation is on a higher floor? Take a second and think about it.
If you said division, you are 100% right. Awesome. Division is on level 3. Addition is on the ground floor. So division has to go first. To divide 3/5 by 2/3, we flip that second fraction to make it 3/2, and then we multiply. That gives us 9/10. Now we can finally do the addition. To add 1/4 to 9/10, we need a common denominator, which is 20. We adjust our fractions, add them up, and we land on our final answer, 23/20.
All right, you ready for the final boss? Take a look at this thing. We've got a square root, we've got parentheses, an exponent, subtraction, multiplication. It's the whole shebang, all in one problem. I know. It looks like a mess, but here's the secret. It's not one giant, complicated problem. It's just a bunch of tiny, simple steps. You already have all the tools you need. And that big square root symbol? Just think of it like another set of parentheses. It means we have to solve everything inside it first.
So let's just chip away at it, piece by piece. Inside that square root, what's our highest priority? The exponent. And we know from before that -7 in parentheses squared becomes a positive 49. Next up is the multiplication. 4 times 2 times 1 is just 8. Look at that. The inside is already simplified down to just 49 minus 8, which is 41. And since we can't simplify the square root of 41 any further, that's it. That's our final answer. See? Not nearly as scary as it looked.
So, when you boil it all down, what did we really learn here? The order of operations isn't just some random list of rules to memorize. It's the grammar that makes math a universal language. It means an engineer in Tokyo and a scientist in Toronto can look at the same equation and understand the exact same thing. It's the system that turns messy, confusing problems into a series of clear, logical steps.
And that, right there, that's an incredibly powerful idea. It shows that if you have the right system, you can take any big, complex, scary-looking problem and break it down into small, manageable pieces. So I'll just leave you with this question. What other seemingly unsolvable problem in any part of your life could you start to tackle if you just found the right step-by-step system? Thanks for watching.